Okay, example 4. This problem, couple things different about it. First thing, there's a square root on both objects. There's also an x and a y. And also it's not a binomial times a binomial, it's a binomial squared. Right? So let me just start off here. Anytime you square something, you're multiplying it by itself. What we're squaring is this expression here. So if I take that expression there, which is the square root of 2, with an x outside the radical, notice the radical stops here, the x is not underneath the radical. I got plus the square root of 3 and the y also outside the radical. It's being multiplied by itself, so it's going to be times another square root of 2 times the x plus the square root of 3 times y. Sometimes the book puts the x or the y underneath the radical, sometimes they don't. You need to pay attention to that. The structure is important when you're doing this problem. Right, but again, anytime you square a binomial, that's what it really means. You're taking the binomial times itself. So it's the exact same kind of problem the last 3 problems were, it's just kind of in disguise. As far as the x and y are concerned, what's going to happen to make it different, when I do FOIL here, the square root of 2 times the square root of 2 still makes the square root of 4. X times x makes x squared. When I do the outside product, positive times positive makes a positive. The square root of 2 times the square root of 3 makes the square root of 6 underneath the radical times xy not underneath the radical. When I do the inside product, the square root of 3 times the square root of 2 makes positive the square root of 6. And yx, or xy if I want to put the same order, both outside the radical because x and y aren't underneath the radical. And last times last, the square root of 3 times the square root of 3 makes the square root of 9. Y times y makes y squared. Alright? At this point, my job is to simplify each object as much as possible. If there's like terms, I need to add them together. Alright? So, first off, let's look at the blue term here. Can I make that any prettier?
Yeah, 2x squared.
Perfect, 2x squared. If you happen to get a perfect square underneath the radical, just evaluate. The square root of 4 equals 2. Okay? Notice these two guys are like terms. X matches x, y matches y, and the square root matches the square root. The coefficients are 1 times the square root of 6 plus 1 times the square root of 6, which makes 2 times the square root of 6 xy. Remember, when you're adding radicals, you add the coefficients. When you're adding x's and y's, you add the coefficients. One of each makes 2 total. Can I make 9y, the square root of 9y squared any prettier?
3y squared.
3y squared. And the square root of 9 equals 3. The square root of y squared is not necessary because it's not underneath the radical. So it just stays y squared. And that's as pretty as I can make the answer. Again, pay close attention to the location of the variables. If they're underneath the radicals, so if it said like this, the square root of 2x plus the square root of 3y all squared. Now all of a sudden it's going to be the square root of 4x squared, which is equal to 2x. And actually it's 2 times the absolute value of x. If it's even inside, not outside, you get about absolute value bars around it, as far as power is concerned. If x is a negative number, negative 3, negative 3 squared is positive 9, the square root of which is 3, but we want to be negative, right? So you've got to be like that. So keep that in mind. That's the one thing the book might throw at you that's a little different with the same kind of problem.